Please tell everyone to join.
Ma'am, can you repeat the syllabus?
Yeah, so anyway, I'll be uploading that. We will have complex numbers, whatever we have learned. Complex numbers. Then hyperbolic function. And logarithm of complex numbers. Then we have partial differentiation up to Euler's. So it will be of 25. So paper pattern will be 10, 5, 5. And this can be further divided to 3, 3, 4. And then 5, 5. Okay, so we'll start with then continuing partial derivatives. So today, composite function. Okay, how do we find partial derivatives of composite function? So composite function means it's function and then it's basically composite. So function and then again inside one more function. So if we say yes. So if u is a function of say r and theta, and r and theta are functions of say x and y. Okay. For example, I say u is equal to so in terms of r and theta, so I can say r square, or say for example r square plus tan inverse of theta, something like that. Okay, so where u is a function of r and theta both, and then r and theta are again functions of x and y. So then we say that u is a composite function. Then we say that u is a composite function of x and y. So first we u and then the last variable that we check. Okay, so in between there can be many pair of variable or many variables, right? But then we will always check at the end. So here what happens, u is a function of x and composite function of x and y. So therefore, we are going to finally differentiate partially with respect to x and y. So we'll find del u del x and we'll find del u del y. Now, how do we find del u del x? So for that, let us draw one tree diagram which will be easier for us to understand. So if I say that this is my first function, that u, and u is a function of r and theta. Okay? And then this r and theta, both are function of x. Use another color. And here r and theta, both are functions of y. Right? So what does it say? That u is a function of r is a function of x, u is a function of r is a function of y also. Similarly, u is a function of theta and theta is a function of both x and y. So in that case, what we do first, and we want to find what this, okay? So we want to find del u del x. Now to find del u del x, because x, r and theta both depends on x, so we have to consider both r and theta here. So first we will find del u del r, okay? And then we will get here what del r del x. But theta also depends on x. So via this path also you can reach to x for u. So therefore, we also have to consider del u del theta, and for this we will be using del theta del x. So there are two paths to reach to x. Hence, del u del x we will be writing as del u del r and then r with respect to x plus del u del theta and then theta with respect to x. Is this clear? So as I mentioned that u is a function of both r and theta, okay, and therefore two variables, hence u we will be differentiating partially with respect to r and theta. Again, this r and theta both are functions of x and y, so therefore we will have what? Partial differentiation of r and theta with respect to x. And because the ultimate aim is what? To find del u del x. But to reach del u del x, we can either select this path, okay? Either select this path, or we can select, we can select this path, or we can select this, right? But then, since we can find del u del x, or we can come to del u del x by this way as well as this way, so therefore we are going to consider both the paths. So one path will be del u del r and then del r del x. The other path will be del u del theta and del theta del x. So therefore we'll have to combine both. So del u del r del x plus del u del theta del x. This is also you can consider as a chain rule. Okay. So for total derivative, you use chain rule. So the similar way here also we are using chain rule. Okay. Similarly, del u del y will be equal to what? First with respect to r and then r with respect to y plus u with respect to theta and then theta with respect to y. So the same path we will be, same concept we will be using here. So in this case we will get, okay, so either u r and then r with respect to y. So this we will get del r del y, this part. And similarly here, this will be as it is, del u del theta, and then here we will get del theta del y. So we have to consider this as well as this and this as well as this to find del u del y. To find del u del y. And always composite function, that first one we will consider, and the last variable at the bottom, whatever variables are there, that we will be considering. So here we will say that u is a composite function of x and y. Okay, so u is a composite function of x and y. Now, while we solve partial differentiation, usually when we apply these formulas, so we usually draw this tree diagram, because this tree diagram helps us to understand that how which path we need to consider to find the partial derivative. Okay. So this is your first one. Then next is, in fact, in the very beginning that we consider that also you can consider like this. So u is a function of r and r is a function of x and y. This already we have done. So if you draw the tree diagram here, so it will be like u is a function of r and then r is a function of x and y. So we can say that u is a composite function of x and y. Okay, so u is a composite function of x and y. So we will be finding what? Del u del x as well as del u del y. So to find del u del x, we have to come via this path, right? So we have to come via this path. So this, and then we will reach here. And to come to this del u del y, so we will have to use this as well as. Okay. So therefore now if we want to write by using the tree diagram, then we can write del u del x is equal to, now here u is the function of single variable r. So therefore it will be what? Du dr, but r is a function of two variables x and y. So therefore r with respect to x, that will be partial differentiation. So du dr into del r del x. Similarly, del u del y will be what? Now u with respect to r. So as again, u is a function of one variable r. So it will be total derivative du dr into, then we will have del r del y. Okay. So this is the same thing that we have already used, but when you draw the tree diagram, then it becomes very clear what derivatives we need to consider and for which variable. Okay. Then third type can be that u is a function of r and theta, and r and theta are function of say t. Okay, let me just change it to x and y for us to fill it in the next case. So here I say that u is a function of x and y, and x and y is a function, x and y is a function of single variable t. So obviously here we can say that u is a function or composite function of t. Okay, one variable t. Now we have to draw the tree diagram to see what we will be getting here. So u is a function of x and y, and x and y is a function of t. So therefore, basically what we are finding derivative of u with respect to t. So when we consider u and t, ये वाली पार्ट अगर हम निकाल देते हैं तो फिर हमें क्या मिलता है? u is a function of one single variable t. So जब भी single variable हो जाता है तो फिर वो total derivative हो जाता है. So here we will be getting what? du dt. But to reach to du dt, so what we need to do, the paths are what? That u is a function of x and x again is a function of t. And u is a function of y also, and y is also a function of t. So therefore, here you can see that u is a function of two variables x and y. So when we will have to come via this path only, right? So via x and then x will be for t. So as u is a function of two variables, so therefore when we will differentiate u with respect to x, that will be for partial derivative. So we will be getting here del u del x, but then again x is a function of single variable t, so it will be dx dt. Plus we can reach to t via this path also. So here again u is a function of two variables, so for y we will get del u del y, and then y is a function of t. So it will be dy dt. So you can see du dt is equal to del u del x dx dt plus del u del y dy dt. One thing you remember that when we have here, the variable, okay. So you can see here, we are differentiating u with respect to x. So therefore, we will have, when we are differentiating, we will have x. There cannot be any y coming here. Okay. Similarly, when we are differentiating with respect to y, so the last variable is only with respect to y. It's y. In intermediate values, intermediate variable we are using r and theta because r and theta both depends on y. Similarly, here when we have here x, here also we have x. There is no y term coming in this because x and y both are independent. Similarly, here also when we have y, here also we have only y. Okay. Same way here we are differentiating with respect to t. So in this case we have dx dt and here dy. I hope this is clear. So next is, we'll continue from here. Suppose u is a function of x and y, and x and y both are functions of x only. What does it mean? X anyway is a function of x, and y is also function of. Okay. So although we write u is a function of x and y, but we have to consider here that y is also a function of. Can you please mute? Can you please mute whoever is talking? Yash Palkar. Yash Palkar. Yash Palkar. Please mute yourself. So you will be remain absent. Yeah. So let's suppose we have u is a function of x and y, and x and y both are function of x. This means that y is also function of x. So if we draw the tree diagram for this, what we will get that u is a function of x and y, okay, and this y is also function of x. That means here x anyway it is a function of x and y is also function of x. So that means what? That u is a function of x finally. Okay. So since here also you can see that we have only one variable at the end. So here what we will get? We will get du dx. Now, so du dx, what we will do, if we find by this one, so we will get del u del x into x with respect to x. That is anyway 1, okay, plus. Next it will be del u del y. And then y is depending on x, and y is a function of x alone. And you can see y is depending on only one variable x. So therefore, it will be what? Dy dx. I hope this is clear. Okay. Now, next possibility we consider, okay, if suppose u is constant. Okay, so if this u is constant, suppose we have u is equal to c. So if u is constant, then in this case, what we will get? So du dx will be equal to 0 because you are differentiating both sides with respect to x. And when you differentiate both sides with respect to x, and because u is constant, so therefore what you will get? Our du dx is equal to 0. So if u is equal to c, then what we will get from here, we will get du dx is equal to 0. Which implies, now what is du dx? Achha, this du dx is equal to 0. That doesn't mean that del u del x will be equal to 0 or del u del y will be equal to 0 or dy dx will be equal to 0. So please, make sure that you understand this. This means u when you are different, because actually we are differentiating u with respect to x. So this du dx, that derivative will be equal to 0. But the way that we have, written this one, del u del x, del u del y, dy dx, they need not be equal to 0. They are not 0. Okay. So here what we'll consider that when u is equal to c, then du dx is equal to 0. But du dx, by using this rule, so what we are getting, del u del x plus del u del y into dy dx, this is equal to 0. Now, from this, what we can find dy dx, and dy dx is equal to minus del u del x upon del u del y. And this is one of the very, very, useful results that we can do. Okay. We can also directly find dy dx, but if we consider in this way, okay, that if we consider that u is equal to c that way, then this becomes very easy because partial derivative is always easy than compared to the total derivative. Okay, so this result is very important. Okay, so this is what all the rules are. So now all problems will be based on any one of these rules. So therefore, to understand which rule to implement, so for that we always draw the tree diagram. It is not mandatory to draw the tree diagram, but yes, if you draw it, then your half of the problem is solved. That way you can consider. Okay. So now let us consider some problem.
Ma'am, y minus dy by dx?
Minus del u del x upon del u del y from here, this equation. So we want to solve only this part, right? So we want to find dy dx. So that will be equal to this. So let us try to solve one problem. Suppose we have, say, z is equal to sine inverse of x minus y, okay, where x is equal to 3t and y is equal to 4t cube. Then we want to find, or we want to prove that dz dt is equal to 3 by root of 1 minus 10. Achha, one more thing. When you are solving all this, now here what you are doing, you are finding del u del x. So your answer should be in terms of x, y. Okay, there should not be any r theta at the end. Okay, final result में आपका x, y आना चाहिए. Similarly, यहाँ पे भी जब आप del u del y find करेंगे, तो final answer should be in terms of x and y. The idea is what? We can always convert r and theta in terms of x and y and find. But then, that sometimes that might be very tedious job to do. Because here we have only two variables, but this we can extend up to n variables. तो बीच में भी हम n variables ले सकते हैं, final में भी हमारे पास n variables हो सकते हैं. So then every time converting those variables into the other variables, it becomes tedious. Therefore, we do not convert and directly we try to apply this, composite functions. Similarly, अगर हम यहाँ पे find कर रहे हैं, say for example we want to find this, say we want to find dy dx. So if we want to find dy dx, then finally my answer should be in terms of xy. So in this case, you can see that z is a function of x and y, where x is equal to 3t and y is equal to 4t cube. And we want to find now dz dt. Now z we are differentiating with respect to t, so the final answer has to be in terms of t. There should not be any x or y present. Okay. Now, first of all, we'll try to draw the tree diagram here. So here what is given, z is a function of x and y, and x and y is a function of t alone. So therefore, my dz dt will be equal to, so you can see now here z is a function of only one variable t. So hence we will get here dz dt. So dz dt will be equal to what? So now for z with respect to x, but then here you can see z depends on, at this level, z depends on both x and y. So we will have partial derivative. So del z, del x, but then x is depending on only t. So it will be dx dt plus del z, del y into dy dt. Now what we will do, we'll evaluate this all separately. So what we have here now, so z, then considering this at this level, when we are differentiating z with respect to x, so we'll assume y to be constant. Similarly, when we'll differentiate z with respect to y, so we'll assume x to be constant. So our z is given to be sine inverse of x minus y. So then first we will find out del z, del x. Now when we find del z, del x, we'll assume y to be constant. So it will be 1 upon root of 1 minus x minus y whole square into del x of x minus y, that is equal to 1. So we have got this. Similarly, del z, del y, that will be 1 upon root of 1 minus x minus y whole square into del y of x minus y, that will be minus 1. Next, what we want dx dt. So what will be dx dt? Now my x is equal to 3t. So dx dt is equal to 3 and y is equal to 4t cube. So my dy dt is equal to 12. So now let us substitute all values in the formula and then see what we get. So therefore, now the left hand side, that is equal to, so dz dt will be equal to, so 1 upon root of 1 minus x minus y whole square into 3. Next it will be, here it is minus, dy dt is minus, so here it will be, sorry, this is minus, the del z del y is minus, so we will get a minus 1 minus x minus y whole square into, here we will get 12t. Now we can take LCM and we will get a root of 1 minus. Now this we can, expand it. So we will get minus x square minus y square plus 2xy. And here we will get 3 minus 12 square. So we can take 3 common and 1 minus 4 square. Now denominator, we want our final answer in terms of t. So therefore, all these we need to now convert to t. So we will get 1 minus x square means 9t square, minus y square means 16t power 6, and plus 2xy. So 2xy means 12 into 2, 24, and then we will have t power. Okay. Now this part we need to factorize, okay, and we'll have to find what we will get factors. Now here one thing, because we have to prove here that dz dt is equal to 3 by root of 1 minus t square, and here you have 1 minus 4t square in the numerator, so that means you can you can just manipulate that 1 minus 4t square must be a factor of this, okay, or so that you can manipulate and you can see, otherwise you have to factorize this. So if you factorize this, so we can, or else directly you can divide by this and then you will get the other factor. This we can write as 1 minus 8t square, and from here we can take 16t power 4. Okay? And minus, so remaining will be minus t square is remaining. Then we have minus 16t power 6, and from 24 we have taken 16, so it's left out with 8t power. Now again from here we can take t square common, so we'll get t square common from here. So we'll get 3 into 1 minus 4t square divided by root of 1 minus 8t square plus 16t power 4 minus 6t square common. So 1 minus from here 8t square, from here plus 16t power 4. Okay. So which is equal to, now you can write 3 into 1 minus 4t square divided by root of, now this is nothing but 1 minus 4t square whole square, and then we will left out with 1 minus t square. So this part is gone now. 1 minus 4t square divided by 1 minus 4t square into root of 1 minus t square. So these two are cancelled. So 3 by root of 1 minus t, right. This is how we can simplify. Otherwise, what you have to do, what actually you'd have done that x and y you have to replace by 3t and 4t cube, and then to differentiate. So instead of that, we are not doing it. So we are simply finding the value. Let's try another one, then it will be. I hope this is clear. So we have z is equal to x square y plus y square, and x is equal to log t, and y is equal to e power t. So find dz dt at t is equal to y. So z is equal to x square y plus y square. X is equal to log t, y is equal to e power t. Then find dz dt at t is equal to 1. So let's see here. So first again we will draw the tree diagram. Okay, so z function of x and y. So you can see z is a function of x and y, and x and y are functions of t. So we have got like this. So now we can write down, so therefore dz dt, so z is a function of t, and so dz dt will be del z del x into dx dt plus del z del y into dy dt. Now what is del z del x? So let us find. So del z del x is equal to 2xy into dx dt is simply 1 by t, plus del z del y will be x square plus 2y into dy dt, that is e power. Okay. Now we want at t is equal to 1. Okay. And then what we can do now, let us, write down the value. So x means log t, then y is e power t into 1 by t, plus x square means log t whole square, plus 2 into e power t, so 2y, and then we have e power t. So this is my dz dt. So you can say all the values in terms of t. Now we want what? At t equal to 1. So at t is equal to 1, so dz dt will be equal to, now log 1 is 0, so the whole thing will be 0 here. And from here, this is 0, then 2e, right? So 2 into e power 1, that is e, into e power 1, that is e. So that means 2e square. So this is the value 2e square. dz dt is equal to 2e. I hope this is clear. So when you draw the tree diagram, then it becomes very easy to evaluate. Okay, next we want to consider if u is equal to f of x minus y, then we have y minus z, and then we have z minus x. Then prove that del u del x plus del u del y plus del u del z is equal to 0. Okay. Here, if you see, it's saying that this f or u is a function of x minus y, y minus z, and z minus x. That means you can imagine it's a general, function. So you can imagine that maybe u is something like this: x minus y whole square plus y minus z whole square plus z minus x whole square, something like this. Or you can be written as, say, sine of x minus y into y minus z, yz minus x. Okay. Or it can be any function which involves the variables are nothing but what? In terms of x minus y, y minus z, z minus. जब ये फंक्शन रहेगा तो फिर ये टर्म्स रहेगा x minus y, y minus z and z minus x. Only x, y, z इस तरह से नहीं आएगा. जो भी फंक्शन हम डिफाइन करेंगे u के लिए, तो it will always involve x minus y, y minus z and z minus x. Directly x, y, z इस टाइप का वेरिएबल नहीं आएगा. Like sin x plus sin y ऐसा नहीं आएगा. It will be always sine of x minus y or log of x minus y plus log of y minus z, something like that. Right? So we are saying that u is a function of x minus y, y minus z, z minus x. Now, instead of considering this big thing, okay, that x minus y, y minus z, z minus x, because it involves, minus sign in between. So what we can say that let me consider that my x is equal to x minus y, then big Y is equal to y minus z, and say big Z is equal to z minus x. Then my function becomes now simple to visualize. तो मेरा u जो है वो u क्या हो जाएगा अभी? u will be a function of x, y, z. अगर पहले मेरा u ऐसा था, तो now my u has become what? Simply x square plus y square plus z square. तो ये दिखने में मुझे easy लगता है, so that I can easily work with this now instead of using this, right? So now what I'm considering that my u is a function of x, y, and z. But these x, y, z, they are functions of what? They are functions of x, y, z again. यहाँ पे z नहीं है मतलब what? The coefficient is 0. यहाँ पे x नहीं है, that means x का coefficient 0 है. और यहाँ पे y नहीं है, so y का coefficient 0 है. So if you see the this rule for composite function, then you can see ये बीच का जो variable है, for suppose u depends on r and theta, तो ये r theta ये दोनों ही ये लास्ट जो वेरिएबल्स है कॉम्पोजिट फंक्शन जिसके वजह से हो रहा है, तो ये x y पे डिपेंड होना चाहिए. अगर मान लो ऐसा है कि r is depending only on x and theta is depending only on y, then we cannot say that u is a composite function of x and y. तो बीच में जो भी वेरिएबल्स रहेगा वो वेरिएबल्स एंड में जो वेरिएबल्स रहेगा दोनों तीनों जितने भी वेरिएबल्स है सबके ऊपर डिपेंड होना चाहिए. So in this case, if we draw the tree diagram, then we can say that u is depending on big X, big Y and big Z. But अभी ये बीच में है, right? These are intermediate variables. Now these X, Y, Z, they must depend on all the variables below. So that means यहाँ पे हम देख सकते हैं x is depending on x and y, right? अगर ये देखा जाए तो y हमारे पास है y में हो रहा है और z में हो रहा है, और यहाँ पे अगर कैपिटल Z का आप देखोगे तो z के लिए यहाँ पे z x पे भी है और z z पे भी है. So does it mean that z is not depending on y or x is not depending on z or y is not depending on x? ऐसा हो ही नहीं सकता है कि ये तीन वेरिएबल्स है एंड में और तीनों में से खाली दो ही वेरिएबल में ये डिपेंड करता है और तीसरे का कुछ पता ही नहीं है, ऐसा नहीं हो सकता. So what we need to consider that they all depend on, okay, so it will be like this. अगर नहीं है इसका मतलब है कोफिशिएंट 0 है, right? So x is depending on x, x is depending on y, x is depending on z, y is depending on x, y is depending on y and y is depending on z. Similarly z is depending on x, z is depending on y and z is depending on x. तो हम बोल सकते हैं कि ये u जो है ये u is a composite function of x, y and z. यहाँ पे 3 वेरिएबल्स आ गया है, ठीक है. So u is a function of x, y and z. Means u से लेके ये x, y, z तक अगर हमें आना है तो बीच का जो प्रोसेस है, ये बीच का जो भी पाथ है, they all should be interconnected. They should be connected. मतलब अब अभी u से हम यहाँ तक आए हैं, राइट? ये वाली स्टेप तक आए हैं x, y, z. तो u should be connected to all the three. अब x, y, z से हम नीचे ये small x, y, z तक आए हैं. So that means this x, y, z, big x, y, z must be connected, with all these x, y, z. वो पाथ पूरा जो है वो कनेक्टेड पाथ होना चाहिए. बीच में कोई भी ऐसा नहीं होना चाहिए कि not connected. I hope this is clear. So ये path should be connected. Okay. So now let us so as we have done our tree diagram. So now we know that u is a composite function of small x, y, z. That means अभी हमें ये पता है कि हमें differentiation किससे करना है, ये small x, y and z से करना है. So we need to find del u del x. Okay, then we need to find del u del y and del u del z. So let us first find del u del x. So del u del x के लिए क्या होगा? U first with respect to x and x with respect to small x. U with respect to y and then y with respect to x and then u with respect to z and then z with respect to x. जितने भी पाथ है x तक आने की सारे पाथ हमें कंसिडर करना है. So one path is like this. Okay. Second path will be like this and the third path will be like this. So we need to consider all these paths. So therefore del u del x क्या आ जाएगा, और यहाँ पे आप देखोगे तो u is depending on 3 variables, मतलब पार्शियली होगा. सिमिलरली ये भी 3 वेरिएबल्स पे डिपेंड है, मतलब सब में पार्शियल डेरिवेटिव ही आएंगे. तो del u del x and then del x प्लस नेक्स्ट ये वाली पार्ट ले लेते हैं, सेकंड पार्ट. तो del y del u del y and then del y del x plus next one will be del u del z and then del z del Okay, if you're not comfortable with writing, like big X and small x, don't get, confused with that. So in that case, you simply, instead of x, y, z, you can write PQR. So that is also fine. Similarly, next हम find करेंगे क्या? अच्छा, let us anyway evaluate this. Now, what is del u del x? हमें function क्या है नहीं पता है, right? If we know the function u कैसे define किया है, then only we can find del u del x. But यहाँ पे तो हमें function क्या है पता ही नहीं है. ये function ऐसा भी हो सकता है, ऐसा भी हो सकता है, कोई कैसा भी हो सकता है. So we don't know what exactly the function is. जबकि हम जब previous problem किया था तो हमें पता था कि z किस टाइप का function है. That's why we were able to find derivative. Whereas here we don't know u is a function जो है एक्स वाई जेड का, कैपिटल एक्स वाई जेड का, तो किस टाइप का है. सो देयरफॉर दिस वी कैन नॉट इवैल्यूएट, सो वी विल कीप इट एज इट इज. बट हमें ये पता है कि यू को हम कैपिटल एक्स से डिफरेंशिएट कर सकते हैं. सो देयरफॉर वी विल कीप इट एज इट इज. जो पता नहीं है वो एज इट इज हम लिखेंगे, जो पता है उसका डिफरेंशिएशन हम फाइंड करेंगे. अब डेल एक्स इसको x से अगर डिफरेंशिएट किया तो दैट वी नो, बिकॉज x वी नो x इज इक्वल टू x माइनस स्मॉल x माइनस y. सो देयरफॉर इसका डिफरेंशिएशन क्या आ जाएगा, x विथ रिस्पेक्ट टू स्मॉल x, सो दैट इज प्लस del u del कैपिटल y. नाउ y विथ रिस्पेक्ट टू x, अब यहाँ पे x तो है ही नहीं, मतलब कोफिशिएंट 0 है, सो दैट मीन्स del y del x will be 0 प्लस del u del z and then del z del x. So del x del z del x is minus 1. So ultimately what we have got, del u small del x is equal to what? Del u del x plus minus del u del. Okay. Now the same way we will find for del u del y and del u del z. अब हमें next find करना है del u del y. Because u is a composite function of x, y, z. So now next हम लेंगे y के लिए. अब y के लिए कौन सा पाथ है? u x और x से y आ सकते हैं, u y और y से y तक आ सकते हैं, and u z and z से भी y तक आ सकते हैं. So therefore now it will be u with respect to del x and then x with respect to y plus u with respect to big Y and then big Y with respect to y. Then u with respect to big Z and then big Z with respect to y. This is big Z. So now let us see. Same way, we don't know, so we will keep it as it is, del u del x. But x with respect to y, that we know, that is equal to minus 1. Next what we will get, del u del y and then del y with respect to y, that is 1. Plus del u del z and then z with respect to y, so there is no y here, so it is 0. So therefore we have found now del u del y. Next we want to find del u del z. So let us find del u del z. So next we want to find for this. So again see the path, किस तरह से हम z तक पहुंच सकते हैं, u से z तक. तो u से x जा सकते हैं, x से z. Then u से y and then y से z, u से z and then z से z. So therefore now we can find del u del z is equal to u with respect to big X and then big X with respect to z plus u with respect to big Y and then big Y with respect to z and u with respect to big Z and then big Z with respect to. See, is this clear? So in case if I would not have drawn this tree diagram and directly अगर मैं ऐसे लिखती तो शायद visualization में थोड़ा दिक्कत हो सकते हैं. But then when you draw the tree diagram, then it's very clear. You know कि आपको यहाँ से यहाँ जाना है और path कौन सा आपको लेना है. All possible paths you need to consider. That's all. So let us now write. So del u del x ये तो पता नहीं है, and then del x del z, that is 0 plus del u del y and y with respect to z, that is minus 1, and then we have del u del z and z with respect to z, that is 1. अब क्या करना है? Now we come to question. हमें करना क्या है क्वेश्चन में? ठीक है, अब जब कॉम्पोजिट फंक्शंस होता है तो पहले हम क्वेश्चन नहीं देखते, पहले हम ये फाइंड कर लेते हैं, उसके बाद हम क्वेश्चन देखते हैं कि अब करना क्या है. ये कर लिया, नाउ व्हाट वी नीड टू डू. ठीक है, so now del u del x, now we have del u del x plus del u del y plus del u del z, which is equal to, so basically you are adding this and right. So everywhere you can see del u del x, del u del x, del u del x. So you can take common del u del x, and then you can add 1 minus 1 0. So 1 minus 1 0. Next you have del u del y, and then you have 0, 1 and minus 1. 0, 1 and minus 1. Next you have del u del z, and then you have minus 1, 0 and 1. Minus 1, 0 and 1. So finally what you are getting, here 0, here 0, here 0. So this is equal to. See, is this clear? Any doubt? Clear your doubts. Because this is the base. Okay, so afterwards you have to, continue with these type of problems.
मैम इसमें कंफ्यूजन हो रहा है. इसमें इधर जो लास्ट में प्रूव किया इक्वल्स टू 0, इसमें कैपिटल एक्स और स्मॉल एक्स में थोड़ा कंफ्यूजन है.
हम क्या, तो फिर आगे से आप ये दोनों सेम मत लो, आप PQR ले लो. ठीक है, तो यहाँ पे क्या फाइंड करना है? फाइंड क्या करना है? del u del x plus del u del y plus del u del. अब हमने del u del x, del u del y और del u del z इवैल्यूएट किया. यहाँ तक क्लियर है क्या किया है हम लोगों ने?
हाँ हाँ, यहाँ तक समझा है. इसके बाद ये नहीं समझा भाई, del u by del x.
ये सिंपली एडिंग ना, ये 1 2 एंड 3.
क्वेश्चन में तो स्मॉल एक्स दिया ना, हमने तो वो सिर्फ कंसीडर किया ना वैसे.
करेक्ट, हमने इसको फाइंड किया, उसके बाद हमें इन तीनों को ऐड करना है, मतलब लेफ्ट हैंड साइड में जो है वो ऐड करना है. अगर लेफ्ट हैंड साइड ऐड करेंगे तो राइट हैंड साइड भी तो ऐड करेंगे. तो राइट हैंड साइड में क्या है? ये del u del x, यहाँ पे भी है del u del x, यहाँ पे भी del u del x है. तो दैट मीन्स del u del x अगर हम कॉमन ले लेते हैं तो इनसाइड क्या रहेगा? 1 minus 1 and 0.
ये समझा.
हाँ, ओके. So let's try another question, and that's so here it is given if z is equal to f of ub, and this is still we are doing only first order partial derivative. If you see, we are dealing with only first order partial derivative. तो ये बेस है, because later on you will have to deal with second order, third order. तो फिर ये first order में जो हम लोग प्रोसेस कर रहे हैं, second order में भी वही हम फॉलो करेंगे. तो z is equal to f of ub, and u is given as x cos theta minus y sin theta, and v is equal to x sin theta plus y cos. Then prove that x into del z del x plus y into del z del y, which is equal to u into del z del u plus v into del z del v, where so this is what we want to. अच्छा. Now there may be confusion कि हमें कौन से साइड मतलब करना है, राइट? हियर वी हैव del z del x del z del y, यहाँ पे है del z del u del z del v, यहाँ पे है z फंक्शन ऑफ uv and u and v फंक्शन ऑफ x and theta. सॉरी थीटा नहीं होना चाहिए. sorry, x and y. So here theta is constant. So theta is constant. Sorry. So in this case, here theta is constant. So u and v are functions of x and y. So here we have got x, y, u, v. अब हम कहाँ से शुरू करें, right? Whether we should start from right hand side or left hand side, क्योंकि ये ऐसे भी दे सकते थे, u del z del u plus v del z del v is equal to x del z del x plus y del z del y. So that's why in the beginning, जैसे बाकी sums में बाकी like कॉम्प्लेक्स हो, हाइपरबोलिक हो, उसमें हम क्वेश्चंस देखते हैं और उस हिसाब से हम लोग चलते हैं, राइट? वी फॉलो द क्वेश्चन. यहाँ पे हम क्या करते हैं, सबसे पहले हम चेन रूल और ट्री डायग्राम भी ड्रॉ, ठीक है? ट्री डायग्राम ड्रॉ करके हमें जो इंफॉर्मेशन मिलते हैं वो इंफॉर्मेशन पहले हम फाइंड आउट करते हैं. तो इन दिस केस इफ यू सी z is a function of uv, बस इतना ही फॉलो करना है. z is a function of uv and u and v are function of x and theta. Sorry, x and y. Okay, z is a function of uv and u and v are functions of x and y. इसका मतलब क्या हुआ, that z is a composite function of x and y. That means जिसका composite function बन जाता है, हम z को उसी से ही differentiate करेंगे. z with respect to x. So we will find del z del x. अब del z del x के लिए क्या होगा, we have to consider all possible paths. So all possible paths क्या होगा, z से u, u से x, z से v, v से x. So let us write that. So del z del u, and then we have u with respect to x, del z del v, and then we have v with respect to x. राइट, इसका वैल्यू हम फाइंड करेंगे. अब नेक्स्ट जो है वो क्या फाइंड करना है हमें, तो नेक्स्ट वी वांट टू फाइंड z विथ रेस्पेक्ट टू y, क्योंकि z का तो x के लिए आ जाएगा हमारे पास del z del x और y के लिए हमें मिल जाएगा del z del y. So basically we need to evaluate these two. Now to find del z del y, so del z del y के लिए भी हमें all possible path consider करना है. So z से u, u से y, z से v, and then v से y. So it will be z with respect to u, and then u with respect to y, plus z with respect to v, and then v with respect to y. Okay. Now we will see question. हमें करना क्या है, या फिर किस साइड से हमें शुरू करना है. अब what we have found del z del x and del z del y. अब देखो कि ये del z del x del z del y कौन से साइड में है, राइट साइड में है कि लेफ्ट साइड में. तो यहाँ पे हमें मिल गया लेफ्ट साइड में. दैट मीन्स वी नीड टू स्टार्ट विद द लेफ्ट हैंड साइड. ये जहाँ पे भी रहेंगे वहीं से आपको शुरू करना है, ठीक है? So now let us evaluate. So del z del u. Now can we find del z del u? No, because z is a general function of u and v. So हमें पता नहीं है क्या है differentiation में. So we will write this as del z del u, but del u del x. Now del u del x we can evaluate. Okay, so del u del x will be equal to what? Simply cos theta plus del z del v. So यहाँ पे sin theta, cos theta, these are all constant. So del z del v ये नहीं पता है हमें, because z is a general function of u and v. But del v del x we can find, and that is equal to sin theta. Similarly यहाँ पे हमें मिलेगा del z del u into del u del y. So del u del y के लिए हमें मिला minus sin theta plus del z del v into del v del y. So del v del y के लिए यहाँ पे आ गया हमें cos theta. Now let us move to the left hand side of the given problem. So now left hand side is equal to x into del z del x plus y into del z del y, which is equal to, अच्छा अब ये देखो x जो है यहाँ पे क्या है, sin theta cos theta है, right? So let us write here like that. Then x into del z del x. So del z del x means this whole thing. So that means we will be getting as del z del u into cos theta plus del z del v into sin theta. Simply substituting. Then y into del z del y. So del z del y is this. So minus sin theta into del z del u plus cos theta into del z del v. Fine. अब क्या करते हैं हम लोग, यहाँ पे इफ यू सी डेल z del u कॉमन है और यहाँ पे del z del v कॉमन है. So let us take del z del u common. Then what we'll get from here, we will get x cos theta, and from here we will get minus y sin theta. Similarly, let us take common del z del v. So यहाँ से हमें मिलेगा x sin theta और यहाँ से हमें मिला y cos theta. अब देखते हैं x cos theta minus y sin theta is nothing but what? U. So this we can replace by u del z del u, or x sin theta plus y cos theta is my v. So I can write here v into del z del v. Del z del v. And this is nothing but what? The right hand side. So I have got the right hand side. Is this clear? So now partial differentiation, स्पेशली कॉम्पोजिट फंक्शन का जब भी आप सम्स करोगे तो सबसे पहले तो ये देखो कि वो कॉम्पोजिट फंक्शन किसका है, राइट. सो व्हाट एवर वेरिएबल्स यू विल फाइंड, तो आपको उसका पार्शियल डेरिवेटिव, पार्शियल हो टोटल जो भी हो, मतलब जितने भी वेरिएबल्स है डिपेंडिंग ऑन दैट, सो दैट यू नीड टू फाइंड आउट. और ये एक बार फाइंड होने के बाद देन यू सी क्वेश्चन में क्या है, एंड देन अकॉर्डिंगली कहाँ आप ये यूज कर सकते हो वही साइड आप चूज करो, एंड देन ट्राई टू इवैल्यूएट. होप दिस इज क्लियर. एंड यू कैन सी वी आर doing same thing, not any difference. Okay. So we'll do some more problems on this. The second order is also there. एक काम करते हैं, we'll do the second order at the end. Before that, we will try to find out or try to solve, other problems. And second order, takes time. तो फिर एग्जाम में अगर आपके पास चॉइस है, सेकेंड ऑर्डर एक प्रॉब्लम है और फर्स्ट ऑर्डर का प्रॉब्लम है, तो फिर गो फॉर दैट, लीव दैट सेकेंड ऑर्डर प्रॉब्लम. So okay, so I'll leave you here, and next class, so next is from 1 to 3. So next class we'll do. So what we can do, the first half an hour we can do some more problems on partial derivatives, and then we can shift to the practical. So